In this video, we are going to see about discrete memoryless channel. Discrete memoryless channel. A communication channel is a path or medium through which symbol flow to the receiver. And discrete memoryless channel, it is a statistical model with the input X and output Y. The channel accepts the input symbol from X and it generates the response to the Y. The channel is discrete when the alphabet of X and Y are finite. It is memoryless when the current output depends only on current input, not on the previous input. Here, in this diagram, discrete memoryless channel with M input and N output are illustrated. The input X consists of the symbol x1, x2 up to xn. In output symbol is represent y1, y2, yn. Here P of y bar x is represent the channel. This channel is represent channel transition matrix. Channel matrix. Here y1, y2, y3, yn are output, x1, x2, xn are input, and channel probability matrix is P of y bar x. It is the channel transition matrix. And then the input probability of the matrix is represented by the row matrix. P of x is equal to P of x1, x2 up to P of xn. The output probability are represented by the row matrix. P of y equal to P of y1, y2, P of yn. The P of y is equal to P of x into P of y bar x. Here P of x is the input matrix, P of y bar x is the channel matrix, P of y is the output matrix. P of x is the represent in diagonal matrix, P of x D is equal to P of x, P of y. It is the diagonal element. All the diagonal elements having the input probability. P of x comma y is equal to P of x, P of y bar x. It is the joint probability. Lossless channel. In lossless channel, all the column of the channel matrix is consist of only one non-zero element. Then it is called as lossless channel. In this lossless channel, here we have 3 input and 5 output. All this is the x1 is the input and y1 is the output. The probability of occurring and transmitting the data is 3 by 4, and if the probability of transmitting the data from x1 to y2 is 1 by 4. This is the lossless channel. In lossless channel, all the column of transition matrix is has only one non-zero element. And then if we add the row of the probability matrix, if we add the row of the probability matrix, then we will get the 1. Probability is 1. Deterministic matrix. In this deterministic matrix, all the row of the transition matrix having only one non-zero element, it is called as deterministic matrix. This channel, here in noiseless channel, the output is connected with only one input channel. It is a combination of lossless and deterministic channel. Binary symmetric channel. In this, two input x1 and x2, two output y1, y2. The channel is symmetric if the probability of receiving 1 is if 0 is sent is same as the probability of receiving 0 if 1 is sent. The common transition probability is denoted by P. This is the binary symmetric channel. This is the binary symmetric channel. And then mutual information. Here By using the input probability, output probability, transition probability, transition join probability, we define various entropy. H of S is the input entropy. Input entropy is equal to some minus summation I equal to 1 to m P of x log base 2 of P of x, and H of y equal to minus summation j equal to 1 to n P of y log base 2 of P of y. H of x bar y is equal to minus summation j equal to 1 to n j equal to x I equal to 1 to m P of x P of x comma P of yj log base 2 of P of xi bar yj. Conditional entropy H of uh, y bar x is equal to summation j equal to 1 to n summation I equal to 1 to n P of xi comma yj log base 2 of P of yj bar xi, and h of x comma y is equal to j equal to 1 to n I equal to 1 to m P of xi comma yj log base 2 of P of xi comma yj. Here h of s is the channel input entropy. H of s is the channel input entropy. H of y is the channel output entropy. The conditional entropy H of x bar y is the average uncertainty remaining that the channel input is after receiving the channel output. H of y bar x is the average uncertainty of the channel output given that x has transmitted. Joint entropy is the average entropy of the communication channel. H of x comma y is the joint entropy. It is equal to h of x bar y plus h of y. H of x comma y is equal to h of x bar y plus h of y x. The mutual information is defined as I of x comma y is equal to h of x minus h of x bar y bits per symbol. The property of mutual information is I of x bar y x comma y is equal to I of y comma x. I of x comma y is greater than 0. I of x comma y is equal to h of y minus h of y y for x. I of x comma y is equal to h of x plus h of y minus h of x comma y. Channel capacity. The channel capacity is The channel capacity per symbol is defined as uh, C of S is equal to maximum of probability of x I of x comma y, where the maximum is over all possible input probability distribution of x. The channel capacity is the function only the transition property is defined in the channel, and channel capacity. Channel capacity per second or be the symbol or being transmitted. The maximum rate of transmission information per second is RCS. The channel capacity per second is RCS, lossless channel. Here, the mutual information is equal to input entropy, then the channel is called as lossless channel. Here, the channel capacity is equal to C of S is equal to log maximum of entropy is log base 2 of n. Deterministic channel. In this deterministic channel, the information is equal to the output entropy. If the information is equal to the input entropy, it is the lossless channel. If the information is equal to the output entropy, it is called as um, deterministic channel, and maximum of entropy is equal to log base 2 of n. Noiseless channel. A noiseless channel is both lossless and deterministic. The channel capacity per signal is equal to C of S equal to log base to base to n log base to n. The binary symmetric channel. The binary symmetric channel, the information transfer is equal to h of x plus p of log base to p plus p 1 minus p log base to 1 minus p. The channel capacity per signal is equal to C of S equal to 1 plus log base to P plus 1 minus log base to P. Differential entropy. Here, additive white Gaussian noise channel. In continuous channel, an information source produces continuous signal x of t. A set of possible signal is considered as the ensemble average waveform. X of t has finite bandwidth and X of t is completely characterized by the periodic sample value. Differential entropy. Average amount of information per symbol is measured as h of s equal to minus integral of minus infinity to plus infinity f of x of x log base 2 of f of x of x dx bits per symbol. We know that I of x comma y is equal to h of x minus h of x bar y. I of x comma y is also equal to h of y minus h of y bar x. H of y is the output entropy. It is equal to output differential entropy. It is equal to minus infinity plus infinity f of y log base 2 of f of y of into t y. H of x of x bar y, h of x bar y is equal to minus infinity plus infinity f of x comma y and x comma y log base 2 of f of x f of x of x bar y into dx dy. H of y bar x is equal to minus integral of minus infinity plus infinity integral of minus infinity plus infinity f of x comma y x f of x comma y log base 2 of f of y dx dy. And Shannon-Hadley law. In additive white Gaussian channel, the output is represented as y and x is the input, n is the additive band-limited Gaussian noise with 0 means variance equal to sigma square. The capacity of the channel is represented C of x is equal to maximum of f of x I of x x comma y is equal to 1 by 2 log base 2 of 1 plus n. Here s divided by n is the signal to noise ratio at the channel output. If the channel bandwidth B is fixed, output Y is the band limited signal completely characterized by the periodic sample value is taken. Then Nyquist state is equal to 2p. The channel capacity of the additive white Gaussian noise is given by C equal to 2Pc. Uh, Here PCS is equal to PCS equal to P log base 2 of 1 plus SNR. This equation is known as Shannon-Hadley law. Thank you.